Welcome to this session on differentiation, lesson 1B. Okay, we want to look at the rules of differentiation. In our previous session, we managed to do differentiation from first principles, right?
Yes.
Okay, so here, number one, the rule number one is that if C is a constant, if C is a constant and Y is equals to C, then dy dx is equals to 0. Okay, let me again remind you of something. The notation, we said the notation for differentiation can be f prime of x dy dx, remember?
Right. Yes.
Or dx like this, right?
Yes.
And we said all of these things, they just mean gradient. Okay, so we are saying if c is a constant, now what this means is the derivative of a constant, for example, if I give you f of x to be equals to 7, then I ask you f prime of x, the answer is 0. So it means the derivative of a constant is 0. Are we there?
Yes.
Don't confuse this with the limit. The limit of a constant is that constant, but the derivative of a constant is 0. Okay?
Yes.
Are you understanding this? Okay.
Yes.
Then number 2, we have what we call the power rule. And this one is the measure that we use. So after this, I won't have much to say than to go to the questions. So after the power rule, let's say if y is equals to a x to the power n, right?
Yes.
Then dy dx is equals to, this n you are seeing will come down here. It becomes n. It will multiply with a, then x to the power n minus 1. Okay?
Yes.
You understand what happened?
Yes.
Let's look at an example. Y is equals to 10x to the power 7, right?
Yes.
What do you think is dy dx?
It's 70 times x.
70 times x? Okay, so it's 7. 7 will come down just like n, right? And multiply with the
yes.
10, then x to the power 7 minus 1. Are you seeing this?
That's fun. Yes.
So what is 7 times 10?
70.
70. Then it
X
becomes x to the power
6. Yes.
the power 6, right? Then we have addition rule. So on these ones that are coming, they are just an application of the power we used. Okay, so let's just do this. Example, if y is equals to, let me say 3x squared plus 2x, right?
Yes.
For you to get dy dx, by the way, this dy dx, it means we are differentiating y with respect to x. Okay?
Okay. Yes.
So when we are saying the addition rule, you see here, you just apply the power rule and also here the power rule. Okay?
Yes.
All right. So what will happen to the first one? What do we get?
It's going to 6x.
6x. 2 minus 1 is 1, right?
Yes. Plus 2. Plus 2.
Plus 2, right?
Yes.
So if there was a 1 here, it was going to be what?
Plus 0.
Plus 0. Okay, good. So here, there's something you did that that is important here that I would love to make easy. If y is equals to a, x, right? Then
yes,
dy dx is simply a, okay?
Yes.
As long as the power is 1, okay? The derivative of that
yes,
is just the coefficient, okay?
Yes.
If y is 7x, dy dx is what? 7, just like that, okay? So that you don't spend the time saying 1 times 7 x to the power 1 minus 1. Let's just know this, okay?
Yes.
Now, to check before we go to the exam type questions, something funny. If I give you now y is equals to a squared x plus a, right?
Yes.
Then I ask for dy dA. What do you think will be the answer?
TXA.
Aha,
TX.
2ax.
Yeah.
Then plus
Yes. 1.
plus 1, the coefficient here, okay?
Yes.
You see, you are used to x. That's why I changed. Now, let's do what you're used to. What do you get if you differentiate this? dy dx.
If you differentiate a squared x plus a.
Aha, the same.
A
What
squared.
you get a squared plus 0, right?
Yes.
So you need to be checking. You are differentiating with respect to what? In this case, x is the constant. But in this case, x is the variable, a is the constant. Okay?
Yes.
Okay. So yeah, I got you there. Now you've learned something. Okay. Now, what they will now ask you in the exam is this. They now say, determine f prime of x. If f of x, so that's 8.2.1, f of x is equals to x squared minus 3 plus 9 over x squared, right?
Yes.
They want us to differentiate this with respect to x. They want us to find f prime of x. Okay?
Yes.
But from what we are looking at, this question is not in the structure that I know how to differentiate. By that, I mean, it is not all having a x to the power n. This is what we learned to differentiate, right?
Yes.
So the first thing to do is to make sure that the given equation is written in the format that you know how to differentiate. All right?
Mm.
Okay?
Yes.
Now, so since we are not differentiating yet, we still write f of x equals to, right?
Yes.
Okay. Then what do you think we can do here? Because this is the part that is giving us problems here. What do you think happens?
You can take the x up and then make the exponent a negative.
So what will happen? What do I write?
9x minus 2 to the power
9x
minus
to
2.
the power minus 2.
Yes.
Okay. Now that we have prepared it, we can now do the differentiation. Okay.
Yes.
We can now say f prime of x is equals to, now differentiate it for me.
2x minus 0 minus 18
Minus 18
x to the power minus 3.
minus 3, right?
Yes.
Sometimes the question will say with positive powers. So they would want you to change this. Okay.
Yes.
So it becomes minus 18 over x to the power positive 3. Okay.
Yes.
We are using the rule a to the power negative n is equals to 1 over a to the power positive n. Okay.
Yes.
So laws of exponents are here again. All right.
Yes.
Okay. Then we also have the second one. It says determine g prime of x. So again, for us to get g prime, this question which we are given, it's not in the format that I know how to differentiate. Okay.
Yes.
However, we can drive it there. But as we drive it, don't write prime yet because you are not differentiating yet. You are just preparing this. Okay.
Yes.
Okay. So before we fry this, let's marinate it. What do we do? Root x times root x. What do you get?
X.
X. Then give me the expansion.
Minus
Minus
1 root x.
minus 1
root x
minus root x.
plus 3 root x
Plus 3
minus
root
3
x minus 3, right?
minus 3.
Okay.
Yes.
Again, it is still a g of x. I'm not differentiating yet. I'm just simplifying, right?
Yes.
So it's x. Now, what is happening here? What do you get here?
Plus 2 root of x square root.
That's
Root of
2
x, is it?
root of x, then minus 3, right?
Yes.
Again, it's still not ready. What can we do here?
You can make the 2 root of x 2x over to the power 1 over 2.
The power 1 over 2.
Yes.
Root of x is the same as x to the power half, okay?
Yes.
That's from exponents again. Now, it is now in the format that I know how to differentiate. That's only when you now put g prime of x, okay?
Yes.
Okay, so now, if we differentiate here, what do we get?
1.
1, plus
X.
x, because the half and the 2, they will multiply. X to the power?
Yes.
X to the power what?
Negative half.
Negative half, because you did half minus 1, right?
Yes.
Okay.
Minus
So,
0.
minus 0. Okay, that's okay. So it means it's the same as saying 1 plus
1
1 over
1 x
to the
1
power
over
half,
2.
right?
Yes. Yes.
Which is just the same as 1 plus 1 over root 2x. Do you see this?
Yes.
All right. Okay. Now that you are smiling, let me... there you go. Let me just give you another one. This one will take us back to grade 10, okay?
Yes.
Now, if let's say find f of x if f prime of x, if f of x is equals to x cubed minus 1 over x minus 1. Okay.
Yes.
How do you now differentiate this one? Can I show you the concept first?
Yes.
Grade 10, okay? In grade 10, under factorization, there's what was called sum and difference of cubed terms. Do you remember this?
Yes.
Where you dealt with things like a cubed minus b cubed, right?
Yes.
What do you do? Do you remember how it was done?
No.
You don't remember. Okay, let me show you the steps. Now, as it is now, you take the cube root of the first term, or it's as if you are just closing 3, right? You write
Yes.
a. Then here you take the sign as it is, minus, you close 3, you get b, right?
Yes.
In the next bracket, you take the first term, you square it. It becomes a squared, right?
Yes.
Then the sign, you change it to plus, okay?
Yes.
Then next you multiply a and b, it becomes ab, okay?
And it's
Then
plus.
Then plus the last term squared, okay?
Yes. Yes.
Okay. Or if you were given like this, you would again close, but take the sign as it is, then close, then a squared, right?
Yes.
Then minus
Minus.
ab, then again plus b squared, right?
Yes.
You understand these two?
Yes.
They were done under sum and difference of cubed terms, all right?
Yes. Okay.
So now, our f of x, being equals to x cubed minus 1 over, let me write this, over x minus 1, like this, right?
Yes.
It means we need to do you agree that it's the same as saying x cubed minus 1 cubed here?
Yes.
Okay. Do you now see it's a difference of cubed terms?
Yes.
So what do we write?
X plus. No, x minus 1.
Then
x squared. X squared plus. X squared plus x.
Plus x, then plus 1. Okay.
1. Yes.
Are you there? Then over
Yes.
x minus 1, right?
Yes.
Here, we still have f of x, not f prime of x, because we are not differentiating yet. We are just simplifying, right?
Yes.
So now, do you see that the x minus 1 and the x minus 1 will now cancel?
Cancel, yes.
So it means this is what we are differentiating now. You understand?
Yes.
So in the end, your f prime of x is equals to, what do we get?
2x plus 1.
2x plus 1. The job is done.
Can
okay?
you ask?
So you see, the topics of maths end up just connecting like that. We ended up going to our factorization. You see this?
Yes.
Okay. Now that you know rules of differentiation, let me take you back to first principles and show you something, okay? You were given f of x to be 1 over x, right? The rules of differentiation are direct and quick, right? Do you agree?
Yes.
So we could write this as x to the power minus 1. Do you see that?
Yes.
Okay.
Yes.
Then after we can differentiate it and get, you get negative x to the power minus 2, right?
2.
Okay.
Yes.
Which is now the same as minus 1 over x squared, right?
Yes.
So the idea is you do differentiate directly and get the answer quick so that you'll be knowing the answer you must find at the end. All right?
Yes.
You understand now, right?
Yes.
Let's look at the earlier examples as well. Like this one here. On this question, you were already going to know that the answer is going to be what? If you differentiate this direct.
No, this one, it's 6x.
It's 6x, right?
Yes.
So when you now differentiate, you will be knowing the kind of answer you are supposed to get in the end. Check. That's exactly what we got, right?
Yes.
So it means when you are now using first principles, you will be knowing the answer already. That's what I'm bringing to your attention now. Okay. Then we now have what is called average gradient. Okay.
Yes.
So average gradient, by definition, average gradient between 2 points, let's say A and B, right?
Yes.
Is simply the gradient of the line, the gradient of the line joining the 2 points. Okay?
Yes. Yes.
The 2 points. All right. Now, if we are to put a diagram to what I wrote here, you'll be having a diagram, let's say like this. Okay?
Yes.
Then I have point A here. Let's say there's coordinates x1 and y1, right?
Yes.
And point B here with coordinates x2 and y2, right?
Yes.
So a question will come and ask you, what is the average gradient of AB? Average gradient, right?
Yes.
So the definition I gave on top said, it is simply the gradient of a line. We know that the gradient of a line is given by change in y over change in x.
Change in x.
So if you don't know the meaning of the word average gradient, the question would seem difficult, but you're already being asked something you know, right?
Yes.
So average gradient is just change in y over change in x. You get this?
X. Yes.
However, now in the exam, the question won't come with all the data available, and we need now to pay attention to how it comes. So look at this one, the example, okay? The example here says, determine the average gradient of f of x equals to x squared plus 2 between the points where x is 3 and x is 4. You see the question?
Yes.
Between the points. So they brought the word average gradient. Now we know the meaning. It's just change in y over change in x, right? Are you with me?
Yes.
But for you to do change in y over change in x, you must be knowing the x value and also knowing the y value, isn't it? The y values.
Yes.
So if x is 3, we need to know what will be y, right?
Yes.
3 squared plus 2. What do you get? 11, right?
Yes.
So if you do that, you now have the point with complete coordinates 3 and 11. You understand?
Yes.
Then if x is 4, then so this was f of 3, and now we do f of 4, right? It means 4 squared
Yes.
plus 2. What do you get? 18.
18.
So you now have the coordinates 4 and 18, right?
8. Yes.
Therefore, average gradient is simply y2 minus y1 over x2 minus x1, right?
Yes.
Which is 18 minus 11 divided by 4 minus 3. What do you get?
7.
7. You are done. That's how you answer a question on average gradient. You understand?
Yes.
So if you don't know the meaning, the question would seem difficult, but if you know the meaning, it's just what you already know, right?
Yes.
Okay. Are you still fit to try another thing?
Yes. Yes.
Okay. Gradient at a point. So with gradient at a point, I'm going to use this example quickly to explain how it works, right? We are given the function f of x equals to 4x squared plus 8x, right?
Yes.
So I'm going to modify this question. I'm going to just say the first one, determine f prime of x. Let me not do it from first principles so that we don't waste time, right?
Yes.
You know first principles, right?
Yes.
So here, what do we get for f prime of x if you differentiate this?
8x plus 8.
Plus 8, right? We are done. Okay.
Yes.
Then the question says hence. When a question says hence, it means using what you got above, do the following, right?
Yes.
So they want us to find f prime. What is f prime? Determine f prime at negative 4. So what does this mean?
Substitute negative 4.
At x, right?
Yes.
And what do you get?
Negative 24.
Negative 24. Okay.
Yes.
The question goes on to say, what does this answer mean? Are we there?
Yes.
Can I now explain the meaning of the answer?
Yes.
It means the gradient
Is negative?
the gradient at a point x equals to minus 4 is negative 24. Are we there?
Yes.
So remember we said f prime of x means gradient. Do you remember?
Yes.
So now, when you now do this, you are looking at gradient at a point. Are you there?
Yes.
So the gradient at a point where x is minus 4 is negative 24. That's the sentence. Are we there?
Yes.
Okay. Then the other one says, what is the gradient of the function where x is 4? So that's the last one on this. Gradient at 4, right?
Yes.
It simply means substitute. So that's gradient at a. So the gradient at point where x is 4 is 40. We are done. Okay?
Yes.
All right. And I quickly finish the last part. So we have what we call tangents to functions. Okay? The gradient of a function, right, is equal
Yes.
to the gradient of a tangent at the point of contact. At the point of contact. Okay?
Yes.
So the gradient of a function is equal to the gradient of the tangent at the point of contact. Okay?
Yes.
If I want to change this English sentence into maths, the gradient of a function is found by f prime of x, right?
Yes.
And the gradient of a tangent, remember a tangent is a line. All right?
Yes.
So the gradient of a tangent is m, okay?
Yes.
So we are simply saying the gradient of the function is equal to the gradient of the tangent at contact, at the point of touch. Are we there?
Yes.
What we are discussing can come in a form of a picture like this. So if I have the tangent here at this point, this is my point, right?
Yes.
So it is this point where they are meeting. At this point where they are meeting, that's where we are saying the gradient of the tangent. This is your tangent and this is your function, right?
Yes.
So the gradient of a tangent is equals to the gradient of the function here at this point. Are we there?
Yes.
So this knowledge which we just discussed, it leads to answers of a certain kind of question. Can I show you quickly?
Yes.
Determine the equation of the tangent. Now, you see, determine the equation of a tangent. A tangent is a line. So they want you to find y equals to mx plus c, okay?
Yes.
So determine the equation of the tangent to f of x at the point where, from analytical geometry, whenever you hear point, you must have an x and a y value, right?
Yes.
So they said at a point where x is 2. So the first thing you need to do is to find that point. That will be your point of contact, okay?
Yes.
Where they will meet. Are we there?
Yes.
We are saying when x is 2, we want to find y. Are we there?
Yes.
So it becomes 2 squared plus 4 by 2 plus 3. Are you with me?
Yes.
What do you get?
4 plus 8 plus 15.
15, right?
Yes.
So it means this tangent, if we are to put a picture, this is what we have. This tangent, let me say they are meeting here. This tangent and the graph will meet here at 2 and 15, right?
Yes.
Now, so the question wants us to find the equation of the tangent. Determine the equation of the tangent. Agreed?
Yes.
For you to get an equation of a line, your job is to find the gradient and the intercept, okay? But for us to get gradient, we now use the statement. We don't have the gradient of the tangent, right?
Yes.
But we found the point of contact. So this is what will happen at contact. We said at contact, the gradient of the function is equals to the gradient of the tangent, right?
Yes.
Now, let us find the gradient of the function. Remember, our function is given by x squared plus what? X squared plus 4x plus 3, right?
Yes.
So we want to find the gradient of the function. It means we are differentiating, right?
Yes.
What do you get?
2x plus 4.
2x plus 4.
Plus 4, right?
Yes.
But we now want the gradient at a point of contact. What is the value of x at contact? It's 2. So remember, we just did gradient at a point. So this is exactly where it works. Gradient at a point where x is 2. That's what we are talking about. And what do you get?
8.
8, right?
Yes.
So it simply means the gradient of a tangent is equals to the gradient of the function, which is 8. Do you understand? At a point of
Yes.
contact. Do you get it?
Yes.
Therefore, y is equals to 8x plus c. Do you get this?
Yes.
Are you with me? The other twin?
Yes.
Okay, good. Now, for us to get c, we must have a point. But from the picture, do you see that the line itself is passing through the point 215?
Yes.
Yes.
So it means we can use that point to find c. So it is 2 here and 15 here. This is x and this is y, right?
Yes.
So 15 is equals to 8 by 2 plus c. Do you agree?
Yes.
Yes.
15 minus 16 is equals to c. So c is equals to minus 1, right?
Yes.
Therefore, y is equals to 8x minus 1. You have found the equation of the tangent at a point of contact, which was 215. Okay?
Yes.